Welcome to Ask and Learn.
So here we know the domain is x is all real. There are no asymptotes because it's not a rational function. So no asymptotes. And we know that the symmetry is even because when we do f of x is equal to f of negative x. So this is even. And for our intercepts, we have, if we set y equal to 0, we have 0 equals the cube root of x squared minus 1. And so take this side to the power of 3, this side to the power of 3. And we are left with 0 equals x squared minus 1. So we can see that x is equal to plus or minus 1. And similarly, if we plug in 0 for x, we are going to see y equals the cube root of 0 minus 1. So we see that this is 0, 1. 0, negative 1 is an intercept here. So 0, negative 1 is an intercept, as well as from this one, we see it's plus or minus, comma, plus or minus 1, 0 for our other intercepts. And now we have to find y prime because the first derivative test allows us to see increasing and decreasing intervals. So if this is y, then y prime is 1/3 x squared minus 1 to the power of negative 2 over 3 times it's on the inside, so 2x. Y prime equals 2 over 3x times x squared minus 1 to the power of negative 2 over 3. And if we set this equal to 0 to find critical points, x is equal to 0, and x is also equal to plus or minus 1. So let's do the first derivative test. This is f prime. And put our critical points. We have 0, negative 1, and positive 1. So we test values in the first derivative. Anything smaller than negative 1, negative. Anything in between negative 1 and 0, negative. Between 0 and 1, positive. And anything beyond 1 is positive. So here we see it's going from negative to positive. So this is a min. So we're done with the first derivative test. So now we have to look at concavity. So now we have our first derivative. We have to find second derivative for concavity. So y double prime is equal to negative 2x squared plus 6 over 9 times x squared minus 1 to the power of 5 over 3. And if we set that equal to 0, we see that x is approximately plus or minus 1.7. It's about, it's the square root of 3. So let's make a line for the second derivative test, testing for concavity. Negative 1.7 and positive 1.7. So here we see anything smaller than 1.7 is going to be negative. Anything we're testing in the second derivative, remember. And then anything between negative 1.7 and 1.7 is positive, and anything beyond 1.7 is negative. So here we see this is positive, so this is concave up. And here it's concave down, and here it's concave down. And also we see a sign change from positive to negative at negative 1.7 and from positive to negative at 1.7. So this is an inflection point, and so is this inflection point at 1.7, negative 1.7 and 1.7. So this tells us the concavity for our graph. Now we can graph it. So here we have (0, -1). So 0, -1. This is an intercept. +1 and -1 are also intercepts. And it's even, so we're going to see symmetry across the y-axis. And now we see that there's an inflection point at around -1.7, so around here, and around 1.7, so around here. So it's going to change concavity. So over here, it's going to be concave down, and around 1.7, it's going to switch to concave up. It's going to hit the axis. It's going to be concave down, and then it's going to go back up here. And it's going to go from 1.7 and beyond, it's going to be back to concave down, so about 1.7, and then it starts to switch back to down. And this is the graph for the function.